Section 2.3 Properties of Functions. Two properties we're going to look at. One is called even and one is called odd. And these properties, the reason we learn them, because they have, for the long run, they help us to save time for graphing complicated functions. So when is the function set to be an even function? So a function f is set to be even if f of negative x equals f of x. So when you try to find f of negative x and you get the function back, that's called an even function. In this case, its graph is always symmetric about the y-axis. Means the y-axis is like the mirror. These two distances are the same. These are the same. These are the same. These are the same. That's an example of it. Keep in mind, when we say x to the n, like any power n, that means the whole x being raised to that n. So if we need to test this function, is this even or not, we always start with finding f of negative x by replacing x with negative x. And notice this will give us, the square will cancel the negative, makes it positive because that's even. So I'm getting f of x back. So that tells us, so f of x equals x squared is an even function. Another example, g of x, 3x to the fourth minus x squared plus 11. Again, we always start with finding g of negative x by replacing every x with negative x. That gives us 3x to the fourth minus x squared, because the even exponents, they make the negative positive. And notice we got g of x back. It's the same as the original function, so it's even. That's about even function. Now, what is odd function? A function is said to be odd if f of negative x equals negative f of x. So equals its opposite, not the function itself. And in this case, its graph will be symmetric about the origin. Let's look at this one. So if we need to find f of negative x, that's negative x to the third power. So f of negative x equals, because it's an odd power, you can take the negative out. So always, if you have an odd power, you can take the negative out and make it like this. If it's even, that will cancel the negative. So that's a negative x to the third. So what does that give us? That gives us f of negative x is negative. That's the function itself, right? Negative f of x. So that tells us this f is an odd function. F is an odd function, and hence symmetric about the origin, its graph. Let's look at more examples now. Test for symmetry. Is it even or odd? And is it symmetric about the y-axis or the origin? That's one example. So again, we always start with finding f of negative x. Replace every x with negative x. What does that give us? That's an odd one, so it's negative 2x cubed, 8 minus 3, negative x squared. So this function here is f of x, so it's negative f of x. So this tells us it's odd and symmetric about the origin. Another example, f of x equals the absolute value of x over x to the fourth plus 1. So we find f of negative x, the absolute value of negative x over negative x to the fourth power plus 1. So f of negative x equals, the absolute value will cancel the negative sign all the time, divided by x to the fourth, because that's an even, it cancels the negative, plus 1. Oh, that gives me the function back. So it's even and symmetric about the y-axis. How about the next one? Another example. So same thing, we're gonna find f of negative x. F of negative x equals negative 12, negative x to the third plus negative x. This gives us f of negative x equals negative 12, negative x cubed minus x. So the negative negative, that becomes positive 12x cubed minus x. You have to watch carefully here. That's not the function itself. Always ask yourself, is it the function itself or negative the function? Let's see, if I take a negative out, what does that give us? Negative 12x squared, negative 12x cubed plus x. Oh, that's the function there. So it's f of negative x is negative f of x. So it's an odd function and symmetric about the origin. Let's write another example. Say f of x equals 5x squared plus x minus 11. F of negative x. Replace every x with negative x. What do we get? F of negative x is the square cancels the negative, minus x minus 11. Is that the function itself? No, because there's a difference here. And if you take a negative out, no, it doesn't give me negative f of x. So this is neither even nor odd. No symmetric about the y-axis or the origin. Now let's look at a given graph. They give us a graph for us. This is the graph, and they label the points and everything. They want us to find local minimums. Local minimums are the points inside, not on the, they can be on the either end. They have to be inside, and they have to be like a local min is the locally, that's the minimum point the graph could reach. Like this point here is a local min. 4, negative 4. This point is a local min, negative 2, 2. For local max, negative 4, 7 is a local max. We have 1, 5 is a local max. And also 7, 4 is a local max. Now for absolute min, that's the lowest point the graph can reach, which is 4, comma, negative 4. Although it was a local min, it still can be called absolute min. Absolute max, the highest point the graph could reach is negative 4, 7. The highest point. It can be at the end points, at the edge. Like, so if this point like here is lowest, we take it if it's the lowest point, even if it's at the end points. That's only works for the absolute, not for the other one. Not for the other one. Not for the local, just works for the absolute. Now, when is the graph increasing? The graph increasing from negative 6 to negative 4, and then from negative 2 to 1, this is 1, and then from this point here, 4 to 7. So we can write it here as an interval. It's increasing from negative 6 to negative 4, union, negative 2 to 1, union 4 to 7, and decreasing from negative 4 to negative 2, union 1 to 4, union 7 to 8. That's where it's decreasing. So let's look at another example here. Let's say we have this. Where's the local minimum? I see 2, negative 2 is a local minimum. Local maximum is negative 2, 4, and there's 5, 4. Notice this point is the lowest point the graph can reach, but it's not local. It has to be inside. It can't be at the end edges, at the end points. How about the absolute min? The lowest point the graph reach, again, this point, 7, negative 5. That can be an absolute min. Some people call global min, absolute min or global min. Absolute max, the highest point the graph reaches, is actually these 2 points. They're at the same level, not drawn to scale, because they have the same y coordinates. So negative 2, 4 and 5, 4. You can have more than one absolute min or more than one absolute max. The same way, the same thing is for the increasing. If you look at the graphs, the graph increases from negative 3 to negative 2, union 2 to 5, and decreases otherwise, negative 2 to 2, union 5 to 7. That's where it's decreasing. Another thing to learn in this section, if we have any function f, label everything, and we pick 2 points on the graph, A and B. Then the average rate of change of f from point A to point B. What would that be? So the average rate of change is the difference in the y's over the difference in the x. So it's the slope. So when you do drop a height horizontal line, this is point B, let's call it B f of B. Point A f of A. This distance is delta y, this is delta x. So it's the slope, which is rise over run, slope of this secant line. Rise over run, secant, rise over run. And in this case, it's the whole thing minus this. So it's f of B minus f of A over the whole thing minus this. So it's B minus A. That's called the average rate of change. So if we need to apply this to an example, suppose that f of x is equal to 2x squared minus 4x plus 1. Part A, find the average rate of change of f from -1 to 2. How do you find the average rate of change? So to start with this one, this is A, -1, and B is 2. So we need to find f of 2 minus f of -1 over 2 minus -1. What is f of 2? We can find it on the side. Substitute in the function x2, 2 squared minus 4 times 2 plus 1. That gives me 1. And f of -1 is 2 times -1 squared minus 4 times -1 plus 1. It's 7. So that is 1 minus 7 over 2 plus 1, which is -6 over 3, -2. That's the average rate of change. Now, as part to this, that's the slope. Find the equation. Find the equation of the secant line containing the points -1 f of -1 and 2 f of -2. Always to find the equation of a straight line, we need 2 points here. From this, we need the slope. -1, f of -1, we found it was 7, and 2, and we found f of -2 was 1. So the slope that we just found was -2. We can use y minus y1 equal the slope of the secant line that we just found, x minus x1. We learned this in a previous section. I believe it was section 1.3. So we can pick any of the 2 points. Maybe I want to pick this point. Say this is x1, y1. So y minus y1 is 1. The slope is -2. X minus x1 is 2. Keep this the same. Multiply the -2 in. Then add 1 to both sides. -2x plus 5. That's the equation of the secant line.